Hi, in this video we will learn how one can determine if a matrix is invertible or not by looking at the list of eigenvalues of that matrix. Well, remember that a matrix is an n by n matrix is invertible if and only if determinant of the matrix A is non-zero. What does it mean? It means that if matrix A is not invertible, determinant will be 0, and if matrix is invertible, then the determinant will be a non-zero thing. If and only if means that. Well, then let us start with the fact that A is not invertible. That will imply that a determinant of A is equal to 0. But I can write determinant of A as determinant of A minus 0 times identity equal to 0. Why do I write it this way? First of all, see that A minus 0 times identity is A. Yes, so I didn't change this thing here. So this is basically the same thing, is equal to 0. But why do I write it that way? Because you see that determinant of A minus lambda I is what we called a characteristic polynomial. And if you have a number, you plug it in and you get 0, that means that lambda is an eigenvalue of that matrix. So this implies that 0 is an eigenvalue of A. And you see, this is a new version or new condition for invertibility. Matrix is invertible if and only if 0 is not an eigenvalue of A. Here, matrix is not invertible if and only if 0 is an eigenvalue of that matrix. Well, this gives us another chance to update our fundamental theorem of invertible matrices. Remember, before we had these conditions that all was discussed in some videos. Now I will add 2 more to this. The 13th says that A is invertible if and only if determinant of A is non-zero, and the 14th condition is that 0 is not an eigenvalue of A. So just by looking at the eigenvalues of A, we can determine if the matrix is invertible or not. Well, let's do another fun example for this. Characteristic polynomials of some matrices, A and B, are given. Determine if these are invertible or not. So when you have characteristic polynomial and we want to check if 0 is eigenvalue of that A or not. So is 0 an eigenvalue of A? How do I check it? Well, just plug in 0 into the characteristic polynomial. Well, see, 0 to the power 4 minus 3 times 0 squared plus 2 times 0 minus 1. This is -1. And what does this show is that, well, characteristic polynomial, when you plug in 0, it is not equal to 0. So that implies that 0 is not an eigenvalue of the matrix A, and that implies that A is invertible. So if 0 is not, then it is. How about this one? You see that characteristic polynomial of B, when you plug in lambda equal to 0, it will give us 0 times negative 0 to the power 5 plus 3 times 0 to the power 4 minus 4 times 0. This is equal to 0. That means what? That means that 0 is an eigenvalue of A, and that implies that, well, if 0 is in the list of eigenvalues of A, that means that A is not invertible. So you can simply, just by look at the polynomial, the characteristic polynomial, and say if it is invertible, the matrix is invertible or not. Okay.